What if I told you there's a brand new AI model out there performing right alongside expensive industry titans like Claude Opus 4.8, but doing it for just a fraction of the cost? I mean, it's literally shifting the entire landscape of what we expect from accessible artificial intelligence. Okay, let's dive into this and unpack the secrets behind GLM-5.3-Flash, the low-cost AI disruptor that is turning heads all across the tech world. To map out how this low-cost challenger actually works, from its architecture right down to its hardware, here's our tech dashboard for today. We'll start with the Claude Opus Challenger, look inside the hybrid architecture, explore AI that sees and corrects, dive into benchmarking against the giants, and finish up with running on alternative hardware.
The Claude Opus Challenger. You know, before GLM-5.3-Flash was officially announced by Z.ai, they were actually secretly testing it on OpenCode and OpenRouter. Under the mysterious code name Aux Alpha, it quietly became the absolute most popular model of that entire week. Developers were just eating it up before they even knew what it was.
And the main reason for that massive explosion in popularity, it really comes down to a staggering cost-to-performance ratio. When you compare GLM-5.3-Flash directly against an expensive industry titan like Claude Opus 4.8, you're looking at near parity in performance, but for literally 1/10 the price. No way, right? But it's true. It's giving everyday developers and businesses access to that sweet, enterprise-grade AI intelligence, but without the massive compute bill. To quantify that efficiency, just look at the number 57. That's the model's score on the Artificial Analysis Intelligence Index version 4.1.1. Now, what makes that score absolutely incredible is that it costs just $0.045 per task at discounted rates. To put that into perspective, previously you'd have to pay 10 times that amount just to hit a 57 on this index. GLM-5.3-Flash is radically pushing the Pareto frontier, redefining the absolute best possible balance you can strike between cost and performance today.
Inside the hybrid architecture. So how exactly did they make inference so incredibly cheap without, completely destroying the model's intelligence?
Well, the answer starts with how the model activates its brain power. GLM-5.3-Flash has a total size of 320 billion parameters, but during any given task, it only actually uses 18 billion active parameters. On top of that, they deliberately kept the architecture super light by using just 45 layers. For context, that's about half the size of its predecessor, GLM 4.5, which used 92 layers.
They achieved this using a specific cocktail of technologies, all trained on a massive 30 trillion token corpus. Now, what's really interesting about this slide is the hybrid architecture they built. Linear attention handles the state modeling, while sparse attention uses a lightweight indexer. Then, to keep memory lightning fast across a massive 1 million token context window, they use index pool. And finally, manifold constrained hyperconnections, or MHC, to really drive that scaling efficiency.
Okay, so what does all that highly technical jargon actually mean for you and me? Basically, compared to its larger sibling, the standard GLM 5.3, this Flash version requires 3 times less attention compute and a massive 4.4 times less KV cache size. So long story short, it's engineered from the ground up to be lean, fast, and remarkably cheap to run.
AI that sees and corrects. See, this isn't just a basic text encoding assistant. It's actually the very first natively multimodal model in the GLM-5 series.
The developers put it perfectly. Code lets the model build the world, and vision lets it see the world people actually use. Think about it. For front-end development, the final output isn't just a line of code, right? It's a visual interface. So they train this model to render its own output, visually look at it, and fix layout bugs totally autonomously. It doesn't need a human pointing out that a button is overlapping some text. It just sees it, and it fixes it.
But hey, this isn't just a toy for software engineers. This native visual capability makes it a highly capable partner for everyday office workers too. It can natively read through documents and spreadsheets without needing them converted into raw text first. It can easily generate a presentation on, say, the planets of the solar system, which is honestly wild for a coding model, or sift through complex data to prepare something dense like a 2026 hospitality responsibility report. It's really built for the real world.
Benchmarking against the giants. We've talked a lot about the claims. Let's move to and see how this builds our understanding with some hard data to prove those bold performance claims.
In software engineering benchmarks, the results are simply stunning. On Deep Sway, version 1.1, GLM 5.3-Flash scores a 63.4. It doesn't just crush its predecessor, it actually surpasses the incredibly expensive Claude Opus 4.8. Now, actually, scratch that. It's not a total clean sweep everywhere. On terminal bench, it does slightly trail GPT 5.6 Terra, scoring an 84.3 compared to Terra's 87.4. But the fact that a budget model is actively trading blows in the 80-plus point range, that is a massive jump.
And when we look at complex agentic tasks, where the AI has to plan and use tools over multiple steps, GLM absolutely dominates. It beats Opus on Toolathon Verified, holds a comfortable lead in Automation Bench, and claims the highest score on GDP Val AV2 with a 1773. It is effectively winning the competitive race against Opus when it comes to autonomous agency.
On the vision side, we're seeing a similar trend. For Office QA Pro, GLM scores a massive 62.4 compared to Opus's 48.9, and it also wins in chartography, 78.0 to 75.0. Just as a quick aside, it is worth noting that if you're looking for pure video understanding tasks, like on the Baby Vision benchmark, Gemini 3.7 Flash still leads the pack there. But for layouts and charts, GLM is spectacular.
Finally, running on alternative hardware. This is the plot twist that really broadens this explainer from just a software story into a global hardware competition.
Here is the shocking fact. GLM-5.3-Flash is being successfully served on a large-scale cluster of domestic Chinese AI chips. They are completely bypassing mainstream NVIDIA GPUs, running the model via an SG-Lang inference engine.
To make this cluster work, they utilize what's called an encode prefill decode, or EPD, disaggregated architecture. Basically, it's a hardware serving setup that scales efficiently across tens of thousands of these domestic AI accelerators. And here's the crazy part. A GLM 5.3 infrastructure agent actually helped engineers optimize the very kernels serving itself. The AI literally helped improve the hardware system it runs on.
So the crucial point is this: 3x. Thanks to that EPD architecture and those kernel optimizations, they achieved a 3x improvement in end-to-end serving performance. That brings their non-mainstream accelerators up to an efficiency that's entirely comparable with mainstream NVIDIA GPUs.
If you're eager to get your hands on this, you can access it immediately. It's available for GLM coding plan users with 3 times more usable quota. You can try those self-verifying visual features via browser and computer use in the Z.ai app. Plus, the public model weights are live on Hugging Face for developers to use with local frameworks like SGLang, VLLM, and TokenSpeed.
So we've got a model that's incredibly cheap, natively multimodal, capable of self-correcting its own visual code, and running efficiently on alternative hardware. As the barriers to high-level intelligence continue to fall, I want to leave you with this. Could this cheap yet powerful trend become a real existential threat to big players like OpenAI and Anthropic? The AI landscape is shifting incredibly fast, and it is absolutely crucial to keep an eye on where this goes next.